Hello everyone, welcome back to my YouTube channel. So today I'm going to be explaining you a prominent topic of Leetcode, which is in medium level. And the Leetcode problem over here is container with most problems. So I'm going to be explaining you firstly the approach, and then we'll be live coding you. This problems looks a bit dicey, I could say. There are a lot of conditions imposed over here, and you also have to try out various test cases, your different approaches. So before delving into starting jumping into the code of the problem, it's always very important to first understand the question, read it thoroughly, try it with different test cases. So when I say test cases, you can take pen or paper, or you could even dry run it with different test cases with trial and error, and check for yourself so that you come with a approach. And always, in lead code over here especially, you have over here the related topics, so that these are kind of like hints for you, which will actually help you to identify which topic is this problem taken from, or which it will help you. So if you see here, the topics are array, two pointers, and greedy approach. So I'm assuming that you must be familiar with these concepts. Even if you're not, you don't worry, because I'll be covering you the approach using array and greedy and the two pointer technique especially. So container with most water. Let me read the question over here. You're given an array, integer array, height. The name of the array is height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height at I. So I hope this line is self-explanatory. So you have been given a array which is named a height array, which is of length n. The size of the array is n, so it has n elements. There are n vertical lines. So these, if you see this example over here, it has n vertical lines. So the size, the number of lines or the number of elements are n. The lines are denoting the nothing but the elements, and they drawn such that the two endpoints of the ith line are I, 0. So if you consider over here, this is the ith line. So its endpoints are I, 0 and I, height at I. So basically this is I, 0, and this is I, height, height at I. So basically these are nothing but defining the height and the width of this particular thing. So basically the height, and if you're considering the x-axis and the y-axis, the coordinates. Find two lines that together with the x-axis form a container such that the container contains the most water. So what exactly is this container over here? Container in this particular problem refers to the area. Now when I say area, it's two-dimensional of course, and it is a area which is a rectangle. You can think it of as a rectangular area bounded by the x-axis and the y-axis. Now you have to identify, the task over here is to return the maximum amount of water a container can store. So simply we can say that it is asking to return the maximum area, the maximum rectangular area, which is bounded by two lines, x-axis and y-axis. So before delving into this, we can notice that you may not slant the container. This is a condition which is given here. So when you check this particular example over here, the diagram, it's given that it's starting from here. So if you see, if you consider this to be the first element, say it's the index is 0, right? In Java, you start the indexes of the elements with 0. So let's say this is 0, 1, 2, 3, 4, 5, and so on. So how many are there? 0, 1, 2, 3, 4, 5, 6, 7, and 8. 8 are the total elements, right? The total number of elements over here. And there are different bars. So what are these bars actually indicating? The bars over here present in this graph are nothing but the heights of the elements, we could say, or the values. So basically the heights. And we have to find the maximum area of the container, or the maximum amount of water a container can store. A container is bounded by, definitely, by two lines, right? With the bars. And it is, when I say bars, it has to be the height, and then a height which is the y-axis, and on the width we say the x-axis. So when you consider the input over here, it says height, which is a height array given, and if you see, this is the test case, 1, 8, 6, so on up to 7, and they are not in sorted order. Now, you can apply two sorted, two pointer approach. You can apply two pointer approach by taking two pointers. So whenever you see an array of elements, and you think whenever it's asking to find maximum area, for area, definitely, for a rectangular area especially, you need length or the height. You need the height and the width, or the length or the width, right? You need the length or the width. So these two parameters have to be considered. So whenever when you think that these two numbers are the ones which you have to find out whenever given an array or a collection like a list, and you have to find two elements or two numbers which actually satisfy a condition, there comes the two pointer approach. So over here, if you say L and H, if you just take the, or L and R, that is like if you take left and right, okay, left and right pointer, and that can be taken as L and R, the two pointers. And using two pointer approach, you could actually find the two numbers which satisfy the condition. The condition is to maximize the area. Now, how do we go about this? And do you think that we can randomly do it, or do you think we have to actually sort this array? I would say that you do not have to sort this array. And basically, two-point approach basically, it reduces the time complexity of the problem. So that is why I'm recommending you to go with two-pointer approach here. And it's also given in the suggestion. It's based on array, two-pointer approach, and the greedy technique. Greedy is because, as I told you in the start of the video, that you have to, try out multiple times. We can do trial and error method. Trial and error. When I say that, it's like you're going to find out the best optimal approach or the best solution for that that point of time greedily, in a greedy way. Okay, so it's like something like not like a recursive method where I say, because if you've heard of dynamic programming, so in contrast to that, you do not have any backtracking, or you do not have to actually undo the steps and go back in greedy approach. It's just like finding the at that point of time whichever solution is the best, the problem is going to consider that solution. So greedy approach over here comes handy. So when you consider this, now let's get into this problem. Do you think that the longest bar is going to actually determine the, the area of the rectangle, which is the maximum water, or do you think the shortest bar? If you actually look into this problem, you will see. And now, when I say to find the area, it's going to be the height into the width. But if you consider the height, if I just say, if you just look into this, which is starting this small bar over here, which is outside this water bar. This water bar is, blue in color. The color blue is because it is the actual correct answer. But if you just ignore the color, the water over there, right? And if you just consider right from here, the black short bar, and not from the red, you consider from here, and the height over here is given as 1, whereas the height of this end bar is given as 7. So when I say to find the height, to find the, the height into the width of the water which can be contained, water will be overflowing if it does not have equal bars, right? For any container, of course, the bars should be equal in length, equal in height also, the two bars on both the sides. So if you consider the extreme ends or the two pointers of the container, they have to be equal length, but they're not of the equal length. So this is the shorter bar, which is of height 1, and the longer bar, the length, it's of the 7. The height of it's 7. So when you consider that, it's going to be definitely the shorter bar which is going to determine the height. You can't say that the height is 7. So if you consider that, the shorter one is 1, and the width is the difference between the R and the L, which is the right pointer and the left pointer. So right pointer, if you say it's over here, when I say it's 8, right? If you consider the element, we had like 8, right? Say 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 0, which is 8. So can you say that 8 into 1 is just 8? So that is 8 centimeters square, which is the area. Now moving forward, do you think that you have to move? How exactly should I like decrement this R pointer? Because in two-point approach, you either have to follow one step. The R pointer, which is in the extreme right, has to either decrement or move backward, whereas the L pointer, which is the starting pointer, the first pointer has to move forward by one step. So you have to move forward by one step over here. The reason being that since the shorter bar is going to determine the height, you can say that this is when you say that the height of the bar at the leftmost counter is less than the height of the bar of the rightmost counter, then increment L. Now, and I say increment L, it means that move one step ahead. Move one step ahead and increment your L pointer. So when you move one step ahead, that is why the reason. It's just you can ignore this now, the bar, and just move forward. Now, when you consider this particular red bar, which is 1, the first index, the first element, the height over here is 8, and the height over here, this will remain constant. Okay, the R will not change, it will not move. The L will move here because the height at L, which is the height of the element at L, of the bar at L, is less than the height of the element at the rightmost index. So when it moves over here 8 and this is 7, the shorter bar, as I told, it's going to indicate the height of the container. So the height of the container over here is 7, and over here if you consider the width is going to be 8, since the index is over here 8 minus 1, which is 7. Okay, over here I think it's they have considered it to be one. It's the indices are not starting from zero. Since it's over here, if you see the origin is starting from zero, so this bar has index one rather than zero. So you can consider it to be like instead of 8, it will now become 9 over here because it says 0, 1. Starting is 1 basically. This bar is 1 and not 0. That's the only difference. So that's only how they have assumed here because origin is 0. I hope I have made it clear now. So if this is 9, so if you say 9 minus, initially it was 1, right? So 9 minus 1 is 8. And 8 into 1 is just 8 centimeters square or any unit square because it's the area. If you consider this, it's 8 and this is 7. So the height is going to be the shorter bar, which is 7, and the width over here is going to be r minus l, which is the rightmost index, or the counter minus the leftmost index. So if you see here, it's going to be 9 minus. So if you consider this as 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to be this is going to be 9 minus 1 and 2. So 9 minus 2, which is 7. So 7 into 7, which is 49. So right now we got 49 as the area of this container, which is starting from this particular red bar, which is the first index, and followed by the last extreme most index. Now if you consider this height over here is not, smaller than this height of the element present at the leftmost index is greater than the height of the element present at the rightmost index. So in that case, rather than incrementing the L pointer and moving further, you have to decrement your rightmost or the extreme right pointer. So you're going to decrement and move somewhere over here. Now, if you move from the last index to the second last index, now there is this black bar over here, then it's going to be 8 over here, the index, right? So it's going to be 8 over here. And if you see 1, 2, 3, 4, 5, yeah, it's going to be 8 here. 8, and this is going to be same, which is just 1 and 2. So 2 over here and 8 over here. Which one is smaller? So if you see the height, this is 3 units, and the height over here is 8 units. So you consider the shorter bar, which is 3 units. 3 into this is 8. 8 minus 2, which is 8 minus 2, which is 6. So 6 into 3 is going to be 18. 18 unit square. Now consider the maximum area. In the initial step, when we had the initial area we said was 49, and this is just 18. So do you think that the initial area is greater or this one is greater? Which one is maximum? The maximum one is to be returned, right? The question says return the maximum amount of area. After, even though we apply 2 pointers, move 1 step ahead if it's in the case of L pointer, or move 1 step behind, decrement the pointer if it's in the rightmost pointer. The main agenda over here in this problem is to find the maximum area, or the maximum amount of water the container can contain. So in that case, we can ignore the previous area, and we can just consider we can take the previous area and ignore this current area, which is 18, because 18 is smaller one. So it is the previous one, which is 49. Now, when do you think this, incrementing and decrementing of the pointers will, moving ahead, manipulating the pointers will actually continue? This is going to iterate or continue till the particular L pointer is less than the R pointer. We can say that when you have decremented R in such a way and incremented L based on the condition which I've told, height of the element at the L position or the left pointer is less than the height of the element at the right pointer. That has to be satisfied, right? Once that is satisfied, and till when it's going to be continued is when you have observed that when the left and the right pointers have come at a at the common point, right? We can say that is the step when you have to stop. That is the point where you have to stop your iteration. You cannot move further, right? Because that's the same. Otherwise, you can say when L is less than R, that is the leftmost index is less than the rightmost index, the counter, right? It's not the index, the counter, because the counter is something pointer which is moving. So when we say L is less than R, the moment you see that L becomes equal to R or L becomes greater than R, that is where you understand that you have to stop your iteration. You have to stop moving your L forward or incrementing your L, or you have to stop decrementing your R. So that is where you have to understand this. So I hope I have made 2 points clear over here in this particular problem. One, that the shorter bar out of the 2 is going to indicate, or it should indicate the height of the bar, right? In the container, since you have to find the maximum area of the rectangle is found by the height versus the width, right? Height into width or length into breadth. So when you are considering the length or the height, right? The highlight, I say the length, it's just this y-axis, and width over here is the horizontal. Length is vertical. So when I say which one to consider, it's a shorter bar which you have to consider as the height. So that is to be considered. And another point you have to remember is that how to find the width. You can just observe over here, and you can say that r minus l, or the rightmost pointer minus the leftmost counter, is going to give you the width of the particular rectangle. That is to be understood, and apply the two pointer approach as it is, and I'm sure that you will be able to understand and crack the logic, and it will definitely give you. So if you keep on doing this by trial and error, moving left and then decrementing right, moving the left pointer ahead, and at the stage where you come together, not only this, but even not only you're like calculating areas for each and every step by moving ahead and backward, but you have to also compare it to the previous result. That is why it is called as a greedy technique. Now I hope I have understood this is self-explanatory. This is an array problem. You have used two pointer approach, and it is greedy in nature because you're not backtracking. Backtracking is where you're applying this kind of a recursive function to undo the step to move back to the previous state, right? But you're not doing that over here. You're just applying the greedy technique. This is somewhat like a greedy technique or greedy approach, we could say. So that is the reason you are also applying greedy approach to find the maximum area. It's just finding the whichever area compared to the previous result, just the previous result, and the current state, which one is larger, considering that which bar is smaller has to be considered, which is the minimum of the length height of two bars, and the maximum of the areas, maximum of the calculated areas, which is the current calculated area, and the previous, just one step previous calculated area. So that is the approach. So when you see this, it says height over here is 49. It's because the maximum height has to be found. Although you will see that the height is changing, but whichever is the most, the maximum area, that is going to be considered as the maximum amount of water the container can contain. The above vertical lines are represented by array, which is given. In this case, the maximum area of water, which is the blue section, the container can contain is 49. Similarly, another small test case, I would say a very easy one. Just height is 1, and it just says the height array. The height array is just 1, 1. With this, it means that just the height of two bars is 1, 1. So we can say that they are equal. Now, I remember I told that a container can contain water. And if the water will not be overflowing if the two bars, the two legs of the container, or the two sides, extreme sides of the container are equal in length. So you don't you see that this 1 and 1 are equal, right? So when I say that this bar is equal and you have another bar, instead of this red bar, red bar having 8 over here, the second bar is also 1. You just have two bars, 1 and 1. So of course you do not have to perform any two pointer approach. Even if you perform two pointer approach, L and R will collide, and you will see that since they are equal, the height will be definitely 1. The width is going to be 2 minus 1. That is the L pointer, the R pointer minus the L pointer. So R minus L, which is, you see 2 minus 1, which is 1. So 1 into 1 is going to be 1 unit square. So you will see here the output is going to be 1, and there is no further maximum area you can find, right? So that is why you return just 1 and leave. So this is simple to simple problem, I would say, although it's tagged as medium. So you can understand that if you crack the logic present over here, and how exactly some of the aspects, like which bar is going to determine why is it a greedy problem, and how exactly two pointers should actually crack your mind. Had it been the case that it was not related, topics were not given here, still you should be able to figure out which is the approach. So finding the pattern in any data structure algorithm problem is the key. I would say to apply blindly two pointer approach. Of course there are different approaches, but two pointer approach is the most prominent and the most result yielding one, and it is also giving time complexity of order of n, by the way. Time complexity of the problem I'm going to code now is going to be just order of n, which is pretty optimal, right? The best and the worst case is going to be order of n. If you find a different approach, a different naive approach, there's a naive and a very basic approach also to do this problem, but I'm not going to cover that because that takes order of n squared, which is not actually suggestible. So I would not, but definitely you can go with your own approaches. This approach is order of n, which I've explained you right now. So I'm going to code it, and then so I've told you can go with two pointer approach when you have to find a pair of numbers or two numbers. So over here also you're finding two numbers, isn't it? You're finding the two pairs. You're finding the one pair of two numbers, which is nothing but two elements or the bar values which are going to satisfy the condition. And the condition is to find the maximum area. That's it. So that's why I go with 2-pointer, because that simplifies the work a lot. And the constraints, just have a look at the constraints, which is n equal to height dot length. Now, this is very important, because you cannot just set, although you can set L pointer to 0, because L, the leftmost approach is starting from 0. 0 is the origin. So you can say it as L equal to 0. But what about R? Do you think R has to be the N? It depends now. It has to be, if you're setting extreme value, and if you're starting L with 0 and not with 1, then R has to be the length minus 1, the length of the array minus 1. So the length of the array is height, if you say N, is going to be N minus 1, or height dot length minus 1. This height is the array, right? The name of the array. So we're finding the length of the array. So height dot length minus 1. If you're starting with L with 1, then it's going to be just height dot length. And 2 is less than equal to n less than equal to 10 power 5, and this another one, 0 is less than equal to height at I is less than equal to 10 power 4. These are the two approaches you have to just understand, right? So this is a pretty simple problem. Let me just code it to you. So if you see here, I'm going to code in Java. So this is class solution, public int max area. You're passing in the argument an array, which is int array height. Now write int L equal to 0, which is the leftmost pointer. Right, rightmost pointer is going to be, as I've told you, the height dot length minus 1. So height is the array, which is going to be height dot length minus 1. Right, you can just give semicolons and then say int I equal to, this is a much simpler method, just followed by commas. If you're very new to programming, this will be just handy. You can just give commas. And of course, the variable, now this is one more important suggestion for you, although I'm just writing in L and R, but then you can make it more clear and comprehensive variable names. So the variable name can be left, right, or something of your choice, which makes it very easier for your code to debug and understand. Although you can just give it L and R also, not a problem. So you get, that is going to be the 2 pointers. So L is 0, starting with 0, R is height dot length minus 1. Now coming to the area, because we have to find the calculated area in this problem. So just say area is starting with 0, right? You have to initialize the area to 0. You have initialized these 3 variables, just these 3 variables required. Now you have to you have this condition. But now I already told you till when are you actually applying the 2-pointed approach. You are applying the 2-point approach, or you're moving this L forward and R backward till this particular condition, which is L less than R. So while L less than R, that is while the leftmost pointer is less than the rightmost pointer, or when only till that point of time where L and R are not at this collided at the same point. They are not come to the same point, right? Because L moves forward, right goes backward, depending on the condition. Now, while L is less than R, this is like streamlining, or I could say filtering your search space into the relevant search space you want, because you have to find a pair of numbers, right, which satisfy a condition. Where I was explaining you why is this bar got neglected. It's because of this particular condition only. There is some condition which has to be set in order to only to reduce your search space, so that optimizes your time complexity as well. So that is why we are doing this. While less than R is very important. You are placing that condition, because you are iterating a particular set of statements till this particular condition value is true. So while less than R, now just say we have to find while while L is less than R. Also we have to check we have to check a condition that whether the height of the length, before checking this, we can calculate the area as well. So when I say area equal to, now when I told how do you actually calculate the area, you're calculating the area, finding the minimum of the 2 bars and the maximum area. So we can just say we have area. So let's say we have to calculate the minimum. So you have heard of the math functions, which is math package, right? So we have in Leetcode platform, we already have a default. So when I say math.min, just say the height at L, comma, height at R, because the minimum height has to be taken into consideration. Height at R. Then just take it like comma. Okay, we have to multiply. So height, math.min, when you say you're finding this minimum area, how do you find this area? You found the minimum of the 2 bars. After just finding the height, it's not just the height, right? For the area, it will also multiply to the width. What is this width? Width is going to be into R minus L. Let's say R minus L, right? Is the width. Now, this is going to be the height into the width, which is the area. You have found the area. Now comes max area, which is the variable you are going to return. Max area is simply going to be math.max. You are basically finding the maximum area, right? So maximum area of what is going to be maximum area of area, comma, your current area, right? So when I say the area which is present over here, and let's say, all right, so let's say this is found, which is area, and instead of, okay, let's just say max area. So you can do this. Max area is equal to math.max of area, comma, max area. Once that is done, you have to now say a condition. A condition has to be kept, which is if height at L is less than R. Now you're checking, comparing the heights of the two bars or the two elements. So if this particular condition evaluates to true, this is not a brace, this is a this bracket. Now if this height at L is less than height at R, then we can say move your L pointer forward. Now this moves forward, else just move backward, right? This I've already explained it to you, is why you have to go with this. Now this, after you, this is if and else, satisfied, just come out of this particular okay, so this is if. You need not actually need this. If you are putting this, then it has to be inside this curly brace, and you are coming out. This is right. So you're coming out of this while loop now. Now, after coming of the while loop, you have to return the max area, which is the answer. So just return max area variable. That is going to be your final answer, which is the area of the container with the maximum water. Now come on, you just check the braces are balanced. Yes, they are balanced. Now let's just run this and check whether it's going to run or not. If there are any problems, definitely do not need to worry. So yeah, there are problems. So it says mat.min height.length, comma, yeah, there is a variable, the name is incorrect. Let's just check again. Max area. So yes, cannot find symbol max area. Now, this max area has to be initialized, we could say. So instead of writing max area is equal to mat.max, initialize max area as well. Just create another variable, max area equal to 0. Initialize that as well, and then you will be able to compare, because if it's not in area, sorry, this is max. Yes, if you have not initialized max area or any variable, it would not be able to actually compare your current result. Return max area. Just always check that the variable names are very correct. This is very, very important, and you're about to make mistakes that there are you might not be able to actually write there are typos, right? Of course, but make sure that the variable names are correctly, because Java is case sensitive. Yes, it is accepted, so you will see that. Okay, so I've just gone, I think it got accepted and went to the previous problem. Let's go back to the previous problem and see. Yes, so this is my answer. Now, as expected, this is the approach. I'll just skim through it. So, as expected, L and R have initialized L to 0, R to h.length, height.length minus 1, area and max area. The reason I did not initialize max area to 0, that is why we got an error that time saying that max area was not initialized. So, it's always important that whatever variable you have used or declared in your program has to be initialized. So area is 0, which is the current area. Max area is a result, which is going to be the greedy. Using the greedy approach, you're going to compare. Where is the greedy approach applied? It's all just applied over here. Math.max area, max area is going to compare your previous max area, your previous calculated area with your current max area. That is going to be resultant as the max area, which is your final answer. Then math.min height.length, this is going to find the minimum of the heights of the two bars and then multiply it with the width, which is rightmost pointer minus the leftmost pointer, R minus L. And then following this very important condition, which is comparing the heights of the heights or the lengths of the bars. You're going to check if the bar present at the leftmost position of the leftmost counter is actually less or greater than the bar present at the rightmost element, rightmost index. So when you see that, according to that, the pointer is going to increment or the right pointer is going to decrement. Then finally return the max area. So this has successfully executed, and you can see on Leetcode runtime is 4 millisecond and it beats 81.53%. So We can say, that was an optimal solution. And if you ask me about the time complexity is order of n, and the space complexity is also order of n. So that was all about it. The reason it's order of n is because it's using an array of n elements, or the size is n. So that is why it's order of n for both time complexity and the space complexity. Had you gone with any, the brute force approach or naive approach, is going to, take you much longer. But two-pointed approach reduces your search time, search space, and optimizes. That was all about it. So stay tuned on my YouTube channel for more in-depth explanations, projects, and all about tech and computer science topics. Thank you very much. And do not forget to subscribe to my YouTube channel. Stay tuned.